This question is to learn how to apply Lagrange Mean Value Theorem and verification. Determine whether the function 4x cubed minus 5x squared plus x minus 2 satisfies the Lagrange Mean Value Theorem on the interval from 0 to 1. Clearly state the conditions that must be checked and find the value or values of 11 between 0 and 1 that make the theorem hold true. First step is to check the theorem's conditions. To use the Lagrange Mean Value Theorem, two things must be true. First, the function must be continuous on the closed interval from 0 to 1. Second, it must be differentiable on the open interval between 0 and 1. In this case, the function is a polynomial, specifically for x cubed minus 5x squared plus x minus 2, and all polynomials are continuous and differentiable everywhere. So, the conditions are fully satisfied. Next step is to apply the Lagrange Mean Value Theorem. Now, the theorem tells us that there must be at least one point, which we'll call 11, somewhere strictly between 0 and 1, such that the derivative at 11 is equal to the average rate of change from 0 to 1. Let's calculate the average rate of change. When x is 1, the value of the function becomes 4 minus 5 plus 1 minus 2, which equals negative 2. When x is 0, the value is 0 minus 0 plus 0 minus 2, which is also negative 2. So, the average rate of change is 0. That means we're looking for a point 11 between 0 and 1 such that the derivative of the function at that point is 0. Next step is to find where the derivative equals the average rate. Now let's compute the derivative of the function. The derivative of 4x cubed is 12x squared. The derivative of negative 5x squared is negative 10x. The derivative of x is 1, and the constant term disappears. So, the derivative is 12x squared minus 10x plus 1. We set this expression equal to 0 and solve for x. This is a quadratic equation. 12x squared minus 10x plus 1 equals 0. Using the quadratic formula, we get the solutions as open parenthesis 5 plus or minus the square root of 13 close parenthesis divided by 12. We now check whether both roots are between 0 and 1. The square root of 13 is approximately 3.6. So the two values are approximately 0.11 and 0.71. Since both are strictly between 0 and 1, they satisfy the theorem. Therefore, the function does satisfy the Lagrange Mean Value Theorem on the interval from 0 to 1. And the value or values of 11 that make the derivative equal to the average rate of change are open parenthesis 5 plus or minus the square root of 13 close parenthesis over 12, which both lie between 0 and 1. Always begin by checking continuity and differentiability. It's the easiest place to forget and the most common reason students lose marks on mean value theorem problems. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much.